As of the end of the 60s, the concept of externalities was cemented by Pigot. Then the basic model to quantify them was proposed by Ears and Knees, as we explained earlier. And the lacking component was the valuation method of these externalities and price tagging of each. And this challenge was tackled for the first time by William J. Baumol in his article, The Use of Standards and Prices for Protection of the Environment, published in 1971. Baumol's target was to demonstrate how to achieve what is called Pareto efficient allocation of resources. This state is reached when it is impossible to improve the well-being of one member of the society without causing harm to another. In other words, it is the state when resources are utilized in the most efficient manner possible, leaving no room for improvement without negatively affecting someone. This concept leads to understanding the importance of pricing externalities and helps to reach an equilibrium where each participant in the material flow diagram pursues his individual interests, and in the same time all the participants come to a resolution that satisfies all parties and beyond which some parties may of course gain, but others will have to tolerate losses otherwise. The gain comes at a price that others accept to receive as a compensation for their tolerance. Here are the main components of Baumol's proposal. First, he made clear that unless such definitions as damage and value are transformed into cost and revenue, Pigovian tax and Ears and Knees material flow diagram will never migrate from theory books to real economy. Second, he added that the optimal tax level of an externality generating activity is not equal to the damage level it creates initially, but rather to the level it generates if the activity had been adjusted to its optimal level. Let's explore together the proposed example by Baumol to explain his idea. Suppose that each additional unit of output of a factory at the initial stage causes 50 cents worth of damage, but that after the installation of the appropriate smoke control devices and other adjustments, the damage per unit will be reduced to 20 cents per unit. Then, the logical thinking will lead to the conclusion that the correct value of the Pigovian tax is 20 cents, because imposing tax of 50 cents corresponding to the initial smoke damage cost will lead to the excessive reduction of smoke generation to a level that makes the marginal cost of decreasing the smoke emission exceed the marginal benefit. Third, Baumol suggested assigning a representative party to establish environmental and social targets for all the processes that take place within the community and have impact on its ecosystem. This party can be summoned of community representatives, officials, experts, or elected individuals. These social targets could be based on newly developed limits by these representatives, existing international standards, or just recognized resolutions. For example, this party may decide that the concentration of specific elements in the atmosphere within the community boundaries should not exceed a certain level, or the oxygen demand in the effluent produced by local treatment plants should not be higher than a set ppm, or limit noise levels within the community to a maximum decibel level. These targets serve as constraints that the society places on its activity. Fourth, these taxes are dynamic. If the initial taxes do not effectively reduce the pollution levels to meet the predetermined standard, the tax rates can be increased. And similarly, if the initial targets are met easily, the representative party may consider making the standard stricter. Fifth, in his article, Baumol included a chart that illustrates the relationship between welfare and the level of activities that causes marginal net damage. The argument is that accessibility standards should only be used in case the curve over the majority of the relevant range is both decreasing and steep. For example, in terms of the curve PQR in the chart, imposing a tax that reduces smoke output from level OC to OA would improve the air quality and increase the social welfare. However, if the relationship between the social welfare and the level of activity imposing externalities is not consistently decreasing, like moving from S to Q in the chart, this may actually decrease the welfare. As we can see, Baumol made a noticeable effort to determine a method that assigns a monetary value to the quality of life. But his method was not a panacea, as many other economists also contributed to the development of unique methods for monetizing externalities or adopting existing economic theories and methods for this purpose. One such method is the cost benefit analysis, CBA, which estimates and totals the equivalent monetary value of the benefits and costs of a project in order to determine their worth. These projects can range in size and complexity, from power stations and infrastructure projects to training programs and healthcare systems. CBA originated from the water development projects of the U.S. Army Corps of Engineers. At that time, the Military Academy at West Point, New York, was the only engineering school in the United States. In 1879, Congress created the Mississippi River Commission with the goal of preventing destructive floods. In 1936, the Flood Control Act that was passed included a very interesting phrase, and here I quote: if the benefits to whomsoever they may accrue are in excess of the estimated costs. End of quote. This marked the establishment of costs and benefits analysis to comply with the requirements of the Act. Initially, the Corps of Engineers used ad hoc methods to estimate benefits and costs, and it wasn't until 1950s that academic economists acknowledged the Corps method to be of use as a foundation to create a system to analyze public investments. The main pillars of CBA are the following. First, all benefits and costs of a project should be measured in terms of their equivalent monetary value, such as US dollar. Second, CBA must be time-bound in order to account for factors such as inflation, fluctuation of interest rates, changes in consumer behaviors and priorities, seasonality, and other factors that may impact the value of consumer choice over time. Third, valuation should be based on actual behavior, meaning the preferences prevailed by choices that have been made should be reflected in the valuation of benefits and costs. Here is a practical example. The benefit of not building a waste disposal site in a specific location can be measured by offering potential residents to choose from two plots of land to build their family houses on. One is adjacent to a landfill and the other is at a considerable distance. The difference in the prices offered by the potential residents to buy the two plots are the actual demonstration of the benefit gained by living away from the landfill or the social cost of building it. Fourth and last, CBA involves analyzing with versus without the project. In other words, the alternative to the project must be thoroughly explored, and by the way, this is not equivalent to studying before and after the project. Another tool that has been adopted from behavioral into environmental economics is the concept of willing to pay, or WTP. This tool was first used in healthcare in a well-known study on WTA to prevent heart attacks by Acton in 1973. WTA measures an individual's willingness to invest in their own health, whether it be to gain health benefits, avoid health risks, or simply reduce health hazards. It is seen as an indicator of personal satisfaction of well-being that individuals associate with different health outcomes. In environmental economics, this concept is explored through various methods such as collecting statistics, distributing questionnaires, or using other tools. A practical example on how to use WTP in the environmental economics can be exploring the willingness of the residents to pay extra to transport the waste generated in their community to a treatment facility located away from the place where they live, instead of building the same facility within the boundaries of their community and possibly save some money on transportation. Another related tool is willing to accept, WTA, which refers to the minimum monetary amount that a person is willing to accept in exchange for selling a good or a service or bearing a negative externality such as pollution. The most applicable practice here might be what is known as host community compensation. That refers to a payment or other benefits provided by a developer to a local community to offset the negative impacts of a facility or a project, particularly in situations like setting landfills or other large infrastructure projects that face local opposition. This compensation mechanism and amount is usually the outcome of the negotiation between the developer and the community. Choice modeling techniques, such as choice experiments, can be used to estimate the value of WTA as well. Alternatively, contingent value techniques like directly asking respondents what they would be willing to accept in different hypothetical scenarios can also be implemented. Let's summarize what we learned so far. First, externalities are pervasive, and it is impossible to imagine a production activity that does not involve the joint production of negative externality. And that is why residues are unfortunately a necessary outcome of all production and consumption activities. Kenneth Boulding once said, "The goods and bads tend to be jointly produced." Second, externalities should be looked at as transactions that result into assets and liabilities. And when liabilities overweigh the assets generated from an activity, then it is logical to either stop the activity or optimize it. Third, in this context, any investment made to avoid any externality is a tangible transaction that has a financial return that can be rightfully claimed by the investor and compensated for either in the form of a direct payment or indirect subsidies. Such approach eases the access to funds for technology providers to offer solutions to reduce smoke, emissions, noise, and other pollutants. Fourth, according to Bigo, the hindrance to achieve equality of returns is caused by the imperfect knowledge. In other words, the more we educate ourselves about the negative consequences of externalities, the more the demand for socially and environmentally responsible solutions will be. This knowledge will also help overcome the initial rejection of such high cost solutions, as they will not be seen anymore as such when looked at from the point of view of the economics of welfare. Finally, thanks to pioneer economists such as Pigo, Ers, Nies, Baumol, Acton, and many, many others, modern terms like life cycle assessment, environmental impact assessment, environmental social governance have become integral part of the assessment process of the feasibility of any activity if it has the potential to affect the quality of our life.